Welcome to our third topic of our course, that is operating height measuring instruments. In our today's lesson, we are going to talk about techniques of height measurement and the types of leveling instruments. But before we talk about the techniques, what do you understand by the term leveling? So leveling is the process of measuring heights of points above or below the Earth's surface. So when we are going to talk about techniques of height measurements, we're going to talk about how is leveling done, what are the kinds of methods on how you can carry out leveling, on how you can measure your heights above or below the surface of the Earth, and then the types of instruments are the instruments used to measure the heights, basically. So when you're talking about the techniques, you're going to look at two major techniques. That is geometric leveling and trigonometric leveling. Okay, let's dive into our presentation. So geometric leveling, as you can see, it's the determination of height differences using a level and a vertical rod. It may first appear a method as a very simple and yielding the best result method. However, practical applications have shown that carrying out this method is difficult on a rough ground and sensitive to irregular model errors. So, geometric leveling is mostly suitable or mostly preferred on gentle lands where the land is not sloping steeply, because the types of instrument that are being used to measure the levels are not very highly suitable for measuring steep slopes. So when you have a steep slope or a rough ground, it may be prone to errors because the machine may not be as stable to withstand the rough ground, or it does not have the capacity to measure sloping readings. So that is for geometric leveling. And then for trigonometric leveling, height differences are computed using vertical angle and distances in trigonometric leveling and according to the land, time, and observing vertical angle. It can be classified as directional, leapfrog, and reciprocal. With development of electronic total stations, they are able to observe vertical angle and distances with high accuracy. So we'll say geometric leveling is used in gentle grounds. So controversially, trigonometric leveling now is used on sloping grounds because it has the machines used in trigonometric leveling has the capability of measuring sloping angles and distances. So when you have angles and distance, you can easily calculate your heights of those points. So those are the two techniques of leveling or measuring height differences. We just say that the processing of measuring height differences is leveling. So you can just name it leveling or a method of measuring height differences. So in our next, we're going to talk about the types of leveling instruments. Of course, when you're doing a project, you need to have an instrument which assists you in the process. Our first instrument is a dumpy level. Dumpy level is the most commonly used instrument in leveling. Most. I'm so sure even if you have observed the projects on mostly road projects where leveling is required, the dumping level is the instrument which is always used, the dumping level and the reading stuffs of the leveling roads. So in this level, the telescope is restricted against movement in its horizontal plane and the telescope is fixed to its support. Bubble tube is provided on the top of the telescope, but however, the leveling head can be rotated on the horizontal plane. So what they mean, as you can see this instrument, this is our damping level. This is the telescope area. So for the telescope, you cannot move it. You cannot move it up and down, like it's fixed in this position. But the leveling head is from here to here. This whole area is the leveling head. The leveling head can be rotated because sometimes maybe you want to measure, you have set up your instrument facing this way, but you want to measure a target on the other side of the instrument. So you'll have to turn the leveling head to face the other side. So the telescope is fixed in its position, but the leveling head can be rotated. And then the bubble tubes are used for leveling your instrument so that you can get the most accurate results. So from our diagram here, we have the four main types, the four main parts of the instrument. That is the objective lens, negative lens, diaphragm, and the eyepiece. Our objective lens is here. Objective lens, here it is, the objective glass. And then our negative lens, it's always on it's an inside, it's an inside part. The diaphragm is over here, this part, and then the eyepiece, here it is. So the eyepiece is the one that assists us in viewing through the telescope, and then objective lens magnifies the object or the leveling rod. And then the second type is the Y level. The Y level or the Y level consists of a Y-shaped frame which supports the telescope. Telescope can be removed from the Y-shaped support by releasing clamp screws provided. So as you can see, sorry about that. As you can see, this is our Y level. You see this part, it forms a Y shape. If you can be very keen to observe, this part forms a Y shape. Y. Yeah, this is a Y shaped. And this is the telescope. But compared to the dumpy level, adjustments can be rapidly tested in a Y level. So we said in a dumpy level, the telescope cannot be moved. It's fixed, but on this Y level, the telescope can be moved. So the disadvantage of this feature is that it is prone to frictional wear and tear because the parts can be easily opened and removed. So the more if you've observed even with normal spare parts or just normal functional parts, if you're prone to every time adjusting it or removing it and putting it back, removing it and putting it back, it's very prone to friction and or wear and tear. So that is it for our Y level. The other instrument is a Cook's reversible level. Cook's reversible is the combination of a dumpy level and a Y level. The telescope can be reversed without rotation of the instrument, and collimation can be eliminated. The Cook's reversible doesn't have a lot of features. It's just a level that has borrowed some features from the dumpy level and some features from the Y level. Automatic level is like a dumpy level. In this case, the telescope is fixed to its support. Circular spirit can be attached to the side of the telescope for approximate leveling. We say the spirit bubble is used for leveling of the instrument so that you can get accurate results. Compensator can help the instrument to level automatically, and it's also called a stabilizer. So compared to, we've said the automatical level is similar to the dumpy level, but the difference is for the dumpy level you have to level your bubble manually, but for the automatic level, the spirit bubble is leveled automatically. So in our next slide, here's a diagram of how an automatic level looks like. And as you can see from the features, it looks exactly like the dumpy level. This is the objective lens, the eyepiece, the early date is where the circular bubble is, and then the circular level, the leveling screws. But the difference is, you see where the circular level is. For the dumpy level, it's always positioned in a point like this, so that you have to level it manually. But for the automatic level, it is positioned here so that once you set up your machine, the circular bubble is leveled automatically. So that is it for our today's lesson. Basically, we've learnt about the techniques of leveling and the types of instruments of leveling. So we've said the most common technique is the geometric leveling. It's the most common, but it is limited to certain types of ground. And the most common type of level used is the dumpy level. But for the advanced people, they use automatic level because it's faster compared to the dumpy level. So that is it for our lesson. In our next topic, I'll post notes for you to read, and then you can, yeah, we can meet during our next presentation or so. Have a good have a good day. Bye.